boys and girls, it's Mrs. J. Thanks for joining me again. Another little edition of Sideways Math. So hopefully you had a chance to look at the other video that I posted. The link was there for you, and you can always go to YouTube to take a look at the video that had to do with triangles and parallelograms. And these are the two worksheets that you're going to need, 7.5 and 7.6, and you can either, you know, like I always tell you, you can either do it with me, you can look at it on your screen. If you've printed it out and you've done it, that's great. You can use this as an answer key if you want to write the answers down on a piece of paper. Any way you can get math to work right now at your house, I'm good with. So, the first worksheet, the one on the top, you can see has triangles. The one underneath is the one that has the parallelograms. So I'm going to put this one to the side for just a second. And you can see I've already made some notes on this one here, the reteach. And you can see here in the middle, this is the angle, the right angle, and you can see that little symbol. Usually they will always put that symbol for you to let you know if it's exactly 90 degrees or not, because sometimes the angles look really close. And I would always tell you this, it's always exactly 90 degrees if they put that little symbol there for you. So if you see that means that the space that this angle takes up here, from if it was all closed up to up here straight up, that's worth 90 degrees. If it's smaller than that, and we can even use the less than sign, that's kind of how I remember. It's less than 90 degrees. That was the angle that I called an acute angle. And you'll learn this word probably when you're in 4th or 5th grade, but that's called an acute angle. And then an angle that's more than 90 degrees. So if you can envision the 90 degrees going straight up, and this is kind of swung open it farther like a door opening, even past that, we call that an obtuse angle. But we're not going to use those terms today, but just so you know, you can impress your 4th grade teacher with that. All right, so at the bottom, so we've got some different triangles, and what they want us to do is they want us to look at the angles and see if they are a right angle, smaller than a right angle, or larger, and tell how many of them there are. And then to kind of look at the sides and to see if we can tell if any of them are equal in length, and if there are, how many there are. Okay, now some of these might be kind of tricky. I was kind of fiddling with this one a little bit, and I was looking at the angles here. And I was like, well, they didn't put the right angle symbol, and this one has the right angle symbol. So, and they already have a little 1 here. So I'm thinking, really, it's got to be like maybe 91 degrees. I don't know, but they say that there's one angle larger than a right angle and 2 sides of equal length. All right, which you can probably guess. I would say that that's this side and that side are equal in length. So those are the answers that we're going to go with for number 1. I think that's kind of a tricky one. So number 2, well, this is much more clear. I definitely see that there is one right angle. And if I'm looking at the lengths of these sides, I know that these two look close, but this one over here is definitely longer. So there's 0 sides of equal length here. If I were to measure those, none of those lengths of that side of triangle would be equal. Okay. Now, if I were to look at this triangle, and sometimes you have to turn your paper, like I like to look at this one, and I'm like, yep, less than 90. And then I turn my paper and I look at it this way. I'm like, oh, yep, less than 90. Because if I were to envision what a 90-degree angle would look like, it would come up like that. And this one is definitely smaller. And then this one is really close too. This one maybe looks like, you can probably hear my dog barking. That one maybe looks like it's 80 degrees. So these are all definitely smaller than a right angle. So I would say that there are 3 angles smaller. And sometimes it does help to turn your paper. And we have actually no sides of equal length. Okay, all of those are a little bit different in size. So if I look at 4, same thing again. All of these angles are less than 90 degrees. Okay, if I was to turn my paper again, because they're all smaller than a capital L, if that makes sense. That's kind of like a nice way to put it in kid talk. So it has 3 angles smaller than a right angle, and this triangle actually has 3 sides of equal length. So it's called an equilateral triangle. So it has 3 sides of equal length. Okay. Now this one's kind of fun. I love the way these triangles look. If you look here at this big, fat, wide open angle, this is the angle that you have to look at right here. That is definitely bigger than 90 degrees, because that, if you can envision like a straight up and down right angle sign, this definitely opens up farther past the top of that L. So it has one angle larger than a right angle, and 0 sides of equal length, because if you look at the 3 sides of these triangles, they're all definitely different lengths. Okay, and our last one for triangle 6, if we looked at our angles again, okay, tiny little angles, less than tiny little angles, so 3 angles smaller than a right angle, and there's actually 2 sides of equal lengths, because this side and this side are the same, and then this little side is shorter. Okay, so hopefully you did well with that. If it was a little tricky for you, that's okay. I know that this is the first time that we've been going over this, so hopefully you were able to use this for an answer key. If you did well, I'm very proud of you. If you made some mistakes or you didn't quite get it, that's okay too. You've gone over it, and you've learned it a little bit, and you've practiced it and become familiar with it, and right now, that's a really great thing. So let me grab my other paper, and you grab your other paper. Okay, so take a look at this. I'll give you a second to make sure that you have your right paper. And this time what they want us to do is we need to tell whether a figure is a parallelogram. Okay, and remember, a parallelogram is a quadrilateral that has both sides, opposite sides, parallel. All right, and that definition is written right here for you. Okay, so the first 2 are done for us. So if I look and I envision railroad tracks, let's pretend I had 2 going this way. Okay, those lines are never going to cross. And if I look at these lines going this way, okay, those 2 lines are never going to cross or intersect. That's the fancy math word for that. So, is it a parallelogram? Yes. Okay. But let's look over here. Now this says no, because both sides are not parallel. And if I look at this very carefully, these 2 lines here are definitely parallel, like railroad tracks. Those 2 lines are never going to intersect. However, and I don't see my ruler, so I can't grab a straight edge, so I'm going to do this the best I can. If I were to draw these lines and I were to keep going like this, okay, you can see that eventually these 2 lines would cross. So that makes them not parallel. So this is why this is a no. Okay. Now, a rectangle is a special parallelogram, and it has 4 right angles. So you can see here, this is where we would do our 4 little symbols here, our 4 little special right angle symbols. So if I look at this figure, I can see, okay, I can make like a little square there. I can make one there. I definitely cannot make one there, and I can't make one there. Okay, that is not a rectangle. I do not see 4 right angles. If I look over here, that probably looks like a rectangle that you're used to seeing. So that definitely is a rectangle. Okay. Now a square is a special rectangle. That's kind of confusing. A square is a rectangle, but a rectangle can't be a square. A square is a rectangle, however, it has 4 sides the same length. And sometimes you'll see a little symbol that looks like that, and that means that all symbols are the same, all sides. Sorry, that symbol means all sides are the same length. So if I look at this, I can definitely tell, yes, that's a square. But if I look at this shape, now what I can do is I can say these sides are equal in length, Now, when you have another set of sides that are equal in length, sometimes what you'll see is you'll see 2 dash marks. Okay, so you know that the 1 dash and the 1 dash, those sides match, and then these sides match, which is great, but it doesn't make it a square. So our answer for that problem is no. No, no, no. And rhombus. Rhombus is kind of fun. Sometimes people think a rhombus is a diamond. A rhombus is not a diamond. Please don't ever call a rhombus a diamond. It might look like that, but it's not. So a rhombus is a parallelogram with 4 sides of equal length. And some people might say it's a tip square. Sometimes in kid talk we say that. A tip square or a tipped rectangle. Basically what we're talking about is just that there's no right angles in that shape, okay? Like everything kind of goes, it's slanted this way, okay? So for this shape, and our sides are equal, that would be a yes. And over here, this just looks like everything is, and oh, plus I see a right, it looks like a right angle there, and possibly over here too. And it just looks like that's not equal, no, not equal in length, and especially if there's a right angle, it can't be a rhombus. So this is a no. So anyway, I hope you liked our lesson today about triangles and parallelograms. I hope you had success with it. Like I said, no matter how you got the math done this week, if you were just able to look at it or do some of the worksheets or practice, if you can just keep that knowledge in your head about different size angles and whether it's a right angle, more than a right angle, or less than a right angle, and if it's a parallelogram, if it has parallel sides or if it has equal sides, or right angles or no right angles. Those are the kinds of things you need to remember for parallelograms. But I appreciate you joining me today, and I hope you had fun with this, and I'll see you next time.